So let's introduce the second form for quadratic equations. This one, remember, is standard form. It's got the ax squared plus bx plus c. In order to be quadratic, it has to have an x squared. Well, this one has an x squared in it, so it's still quadratic, but it's in a much different looking form. In fact, it looks a lot like point-slope form that we used earlier in the year, but this with the squared makes it what we call vertex form. And that's because the vertex is built right into it. This h and this k, the hk is the vertex point. In this case, it'll be 3 and -8. The formula has negatives in it, so it's the opposite of those numbers. The a value of 2 is just like having an a value in standard form. This is telling us that that parabola is going up, and it's a little bit narrow. So, if we want to graph using this vertex form, since we know the vertex, put that right in the middle of your t-table. And then build some other points around it. Use 4 and 5, and use 2 and 1. Because we know that 3, 8 is the vertex. It's right in the middle. We can graph it, and that parabola, remember, is symmetrical. That's where the middle will be. Now, before you put those values in, this equation is not y equals. So it's a good idea to subtract the 8, get it to the other side, and now we just have y equals, and now we can put in 5, 4, 2, and 1 and see what we get. If you do it correctly, you should get 0, -6, and -6, and 0. Go ahead and give that a try. See if you can get a good graph of this quadratic equation that's in vertex form.